Hello there, we are Group 12 and today we will be doing a presentation on our findings with the Canberra Light Rail Project. Our objective in doing this analysis is to determine whether the Canberra Light Rail Project is financially sensible or not. In order to do this, we use a wide variety of analysis techniques, including net present value, internal rate of return, accounting rate of return, profitability index, payback period, and discounted payback period. We will also be taking a look at forecasted cash flows and will be conducting a break-even analysis.
Before we begin, we would like to take a look at the previous study regarding the Canberra Light Rail Project. In 2014, an infrastructure consultant named Bob Naren studied the project only to conclude that it was not financially sensible. He found that it caused the existing bus system to fail, and that it could not only sustain itself financially. It was employed by the Canberra Labour Party, which paid him $90,000 for his consultancy.
The light rail project is unique in the sense that it is being delivered by the workings of both public and private sectors. This is known as a public-private partnership. This type of arrangement is typical in long-term large infrastructure projects. Because of the size of these projects, the government subcontracts out most of the construction work, but is still in control of the project as a whole. We chose this project because of its close proximity to the university and the unavoidable impact it is having on all of our lives at the moment. The methodology we used to collect the data for this report was pretty straightforward. Most of the information was readily available on the internet. As this is a government project, information such as financial agreements, proposals, and planning documents are required to be accessible to the public. This is advantageous to us because not only is the information easily available, but it is also required to be accurate. While most information was easily available, we were unable to find information on expected annual income and the breakdown of fixed and variable costs. For this information, we have made the following assumptions. The average ride would be $4.50 and we estimate 80,000 rides per day. For the costs, we have got 75% would be fixed and the remaining 25% would be variable.
In our studies, we measured the accounting rate of return, which is the average profit divided by the average investment. To approach this number, we took the expected income and subtracted it by the expected expense, and then divided that by the initial outflow divided by the life of the project, which is 30 years. And then we approached the 415.33%. When you compare this to other accounting rate of returns in the industry, it is much higher, actually several multiples higher. So this should be accepted in this particular instance. We also studied net present value in our analysis, which is the discounted cash inflow minus the discounted outflow. And by doing this, we took the present value annuity for 30 years expected inflow of $108.4 million and subtracted that by the initial discounted outflow of $707.1 million. And we arrived at this number of $638.04 million. This is the expected amount of value that the project will create, and because it is greater than zero, it should be accepted. We also studied profitability index in our analysis, which takes the discounted outflows and divides it by the inflows. This is similar to NPV, except instead of subtracting, you're dividing. In doing this, we took the present value annuity of the expected inflows of cash and divided it by the initial outflow. And to this, we approached 1.90. The acceptance criteria is if it's greater than 1. So at 1.90, we should accept this project. In our analysis, we also studied internal rate of return, which is the rate at which the outflows will need to be discounted at in order to reach a net present value of 0. To do this, we had to use trial and error. So we plugged in a discount rate of 0.15 or 15%, and got 4.65, and then saw that at the 16% it was a negative number. So we knew it was between those two numbers. From there, we added them together, then divided them out by the difference, and we came to 15.11%. Because 15.1% is greater than 7% in this instance, we should accept the project. Here we'll be taking a look at payback period. This is the amount of time it takes to recoup your initial investment. For this, we took the initial outflow, subtracted it by the expected annual income, and we found that it would take 7.22 years to recoup your investment. This is a little misleading because the 7.22 years does not take into account the time value of money. This is particularly important in a project of this length, but still, given that it's only 7.22 years out of a 30-year project, it should still be accepted. Similarly to the traditional payback period, the discounted payback period takes the outflows and subtracts them from the inflows for an X amount of years and tries to get zero. However, in this case, it takes into account the time value of money. So when you do this, you have to take, it's kind of a trial and error approach where you take the present value annuity at different time lengths here, 9 and 10 years respectively, and then from there, you take it and you divide them and you approach 9.02 years. While this is complicated, 9.02 years is still very, very good timing considering the life of the project is 30 years. In that case, and then for this particular instance, it should be accepted as well. We also conducted a break-even analysis in our study, which takes the fixed cost and divides it by the contribution margin per unit. In this case, we had to calculate the variable cost, so we took our 0.25% times the total annual expense, and we approached that number, divided by the numbers of rides per day, and then by 365 days a year, and approached 20 cents per ride. So the contribution margin would be total income, which is $4.50 per ride, minus the variable cost, which is $4.30. From there, we take the fixed costs per year, which is $7.25 million, and divide it by the contribution margin, where we get 4,011,628 rides. This is also equivalent to 50 days out of the year that we need to operate in order to break even. So with there being 365 days in a year, only 50 days to recoup that investment, that is very good, and this should be accepted as well. Lastly, in our studies, we took a look at forecasted cash flows, which is expected annual income subtracted by expected annual expense. The annual income in this instance of $23 million was collected straight from the business plan, whereas the $131.4 million expected income was calculated by taking a $4.50 ride, multiplying it by 80,000 rides per day, and obviously multiplying that by 365 days in the year. In doing this, we approached an average expected income of $108.4 million, and because this is a positive number and it seeks to create lots of value over the life of the project, it should be accepted as well in this case.
When reflecting upon our findings, you can see that each of the indicators used suggest the project should be constructed. This is interesting because Bob Nearen's analysis suggested otherwise. We believe this may have occurred due to the lack of information. When his study was completed, we also believe his tie with the Canberra Liberal Party may have influenced his results.
In conclusion, we hope that our findings contribute further to the existing debate regarding the Canberra Light Rail Project. While our analysis is very quantitative heavy, there were many qualitative aspects that were ignored in an effort to simplify our project. We would like to encourage others to use our findings and apply them moving forward in their own studies. Thank you.